All right, so this is my soil and land cover investigation. The first thing that we were asked to do was look into some standards that align to this. So I picked the next generation science standards. It actually fits into earth science. It's 4ES 2-1 and 2-2, which is just about erosion that's happening to earth based on water, ice, wind, or vegetation. And actually, I really liked that with the next gen standards, it included the science and engineering practices, the disciplinary core ideas, and the cross-cutting concepts, which were in the theory part of this week's module. So I thought that was an interesting connection, and it was just cool to see and definitely made me think a lot more about the theory part. So the question that was asked was, what's the best land cover for a healthy watershed? And we were asked to create an erosion bottle experiment to practice what this looks like. So when I was planning, I gathered quite a few different materials that are here. I got the potting soil from pots that I haven't planted yet for this year. I got these little containers for my runoff from the dollar store, and I actually just used a clump of grass from my backyard. I used the duct tape to attach the twine to my bottles because I was struggling with trying to punch holes in the sides in order to attach the twine. So this is my design. As you can see, I have one with soil, one with like leaves and like kind of just debris from our backyard, and then one with the grass clumps. And then I actually went into the create phase where I started testing. So this is the soil only, this is the soil with debris, and this is the grass. To show you a little bit closer so we could evaluate, as you can see, there's quite a bit of debris. Obviously, the soil has infiltrated this water, and you can see that there's less debris with soil and leaves and hardly any with soil and the grass. So then we moved into the improve stage. So then I started thinking like, well, when I was looking at the simulation, I saw that there were different kinds of soil that you could choose from. And some of the most highly infiltrated soil is sand. So we have a sandbox, and I was like, all right. So one, I just put just sand in, and the other one, I actually put these rocks and then put sand over top. And I wanted to see how that might have changed it. So in this one, the left side is just the sand and the right is the rocks and the sand. And I was kind of surprised to see that there was actually more debris in the water with the sand and the rocks than there was with just the sand, which was interesting because I thought that the rocks would kind of like hold the sand more in place. So as far as next steps are concerned, I found this really interesting erosion lab that someone did on YouTube. I'm going to post the link to it on my discussion post for this, but I thought that was a really interesting piece just to look a little bit further into some of the other things that cause erosion besides water. There's a part about wind erosion and just the different parts of having land cover and things like that. So it's another possible thing to do. And then as far as the STEM practices are concerned, obviously, again, there were some connections between the science and the engineering because there's lots of similarities between the two. We were asking questions, we developed models, we carried out investigations and analyzed and interpreted the data, and we obtained it. We evaluated and communicated the information. And as far as technology and math was concerned, there wasn't a whole lot. It's a stretch to say I used appropriate tools strategically. I tried, but I don't necessarily feel like they were math tools, but it was a stretch, but that's what I have. So that was my experiment this week.